Hi everyone, welcome to another Common Lisp study group. I'm your host Ron Vaden with Atlanta Functional Programming. My apologies for those viewers of last week's episode. We unfortunately were abruptly interrupted due to a fire alarm that was happening in my apartment, in my residence, that I was unable to escape. So I needed to exit the building in my premises, so we had to cut it short. So we're going to be discussing and continuing our discussion from last week on some odds and ends that we kind of alluded to, but were unable to actually complete in detail regarding CL environments. Couple things that I want to bring up prior to the beginning of our discussion, and that is, for one, and I think this is very important to recognize. I kind of made a mistake on explaining CL environment's intent. At least I misunderstood the intent of the entire actual purpose of the environments API that I thought I'd express here today. Rereading chapter 8 on the section on environments, particularly the section on environments, later on it became abundantly clear what the purpose of environments is for, and especially the implementation of augment environment, what its purpose was. And that is, augment environment is specifically used for syntactic analysis. So what does that mean? So it requires us to visit, Lisp has a compilation environment, like a compiler framework, and the different types of macros that are available. Specifically, when we talk about syntactic analysis, you can almost think of it like when you're talking about how would you deal with reader macros, taking non-Lisp syntax and converting it into Lisp syntax. In this particular case, augment environment provides the ability to take Lisp forms and arguments to functions defined in the environments API, and functions such as macro expand that requires information of the functions and expander functions that are available. And the purpose of augment environment is to allow you to potentially provide different transformations to those expansion functions in a way that will allow you to go ahead and change the potential Lisp form and Lisp behavior that's actually being created by the macros. This is important because this means that environments, unfortunately, cannot be passed into, at least in many cases, to many of the CL user functions that are available at your disposal, or the CL functions, to be more exact. CL user obviously includes some additional stuff that's not part of the core Common Lisp language, separate from what have you. But the fact is those functions defined in the CL namespace, in the CL package, they do not have environment as being an optional argument, so you can't necessarily get the definition for a particular set of forms from the actual augmented environment, which means you're stuck with whatever is provided by the null lexical environment. This is why, in many cases, as you saw in the last couple of weeks that we were dealing with CL environments, we were encountering this unbound issue. What was happening was, behind the scenes, the form was being evaluated by the Lisp interpreter prior to actually executing in an in or out fashion. So the innermost function will get, or innermost form will get executed and go out. And what was happening is one of the steps in evaluation, obviously, is symbol resolution. Well, in the case of using a symbol that was defined in an augmented environment, since the core Lisp function that we were trying to use it in didn't pass in or take the environment or read the symbol information from the augmented environment provided, this ended up resulting in us getting a form that was unbound. It couldn't find the symbols. As a result, it ended up throwing up on the exception and taking us into the debugger. So we're going to try and correct that today, particularly in the context of both symbol macros and macros. To begin with, let me just clear my REPL here. We will start with symbol macros. Last time, when we started the stream, before we were abruptly interrupted, we had this symbol macro that we called symlist that we did list 1, 2, 3. Now, one of the things that we have with this is now, since again this is syntactic analysis, this symbol is matching list 1, 2, 3 has a form. It's not actually evaluating it when it gets injected. Okay, this is a very important piece to realize. If we pass in, so one of the things that we can do with this is, and let me just clean this up a little bit here, is we could take this guy and we can actually use the augmented API that was provided by CL Environments, and there are many of them. You can actually see here, if we do augmented, we have augmented compiler macro function, whether it's an augmented constant provided in the top level environment. Get setup expansion, that's for generalized expanders as well as accessors. Macro functions, which is additional functions that are being provided into the actual environment. And I think this includes if you use macro in a macro function. And that's something we'll see later on when we try using, when we try defining our own macro inside the augmented environment, as well as the two macro expansion functions that leverages the third argument as being the argument to be passed in to do macro expansion. Now, the first thing that we're going to do is we're going to try and use macro expand to actually go and cover the case where we are going to try and print something to the, macro expand 1, where we are going to try and print something to the console. And what this is going to return to us is obviously the macro expansion of print symlist there. As you can see here, one thing to note is our symlint is quoted. For some reason, if we did not quote this, and I learned this last time, what ends up happening is when you try to compile the function, Lisp is attempting to use this symbol or bind this symbol at the null level. It's attempting to look up the symbol at the null lexical environment level, not at the level of this. I tried several things, and I can show you some of the stuff that I tried just for folks who are looking at it, and the more knowledgeable folks, if I made a mistake, obviously put a post in the YouTube comments so I can go and correct this to update this material, which has a record. But to begin with, if we try running this information, we can actually now see that we get print variable information, and we actually get the symbol macro that it's true because it is a locally bound symbol macro, and there are no declarations attached to this particular symbol macro. Where is this other symlist coming from? My guess is the symlist is coming from us actually attempting to print the augmented expanded environment, but not entirely sure. That is an interesting thing to know. Let me just make sure that I'm not accidentally printing anything at the top level of this. No, I'm not. Okay, good. So let me just quickly do a describe here, just to make sure I did not C augmented macro expand 1. Okay, so now just to compile the function that ends up using, and it's supposed to, let me try this. Let me see if I can actually, 1 second. Okay. Let's see if I could open up this guy. Where is this located? CL environments, other SBCL.lisp. Okay. So, let me just quickly open this guy up here. Go back, do Lisp, quick Lisp, this, quick Lisp, software, CL environments, other SBCL. Yeah. Okay. One second. Okay. So this guy uses augmented macro expand 1. Let's see, where is this defined? Augmented macro expand 1. There it is. And this guy just calls macro expand 1 function with the optional thing. Okay, so this is actually just passing in the augmented macro to the underlying implementation that's on SBCL. Okay. So, so now we have this. Again, as I mentioned, if we end up trying to use, say, this and try to quote it, you're going to get a different execution here, which mainly is going to say print symless. It's not going to attempt to actually expand that print because this is obviously the form that it's getting, which is a quoted form. In this case, though, the fact what it's doing is it's taking what symlist is, and it's going to attempt to grab the list 1, 2, 3, and since we quoted it, it's just going to inject the list 1, 2, 3 has it, which is why you get this list 1, 2, 3 here. We're trying to actually get it to being just 1, 2, 3. Okay. You can attempt to do this, but again, like I said, when you try this, it's going to try and get the symbol symlist from the null lexical environment, and you'll end up, getting these unbound warnings. So, again, to repeat myself, and I'm just going to be just kind of stressing this home. CL environments, particularly the augment environment API and implementation, will always be used for syntactic analysis. It's not going to be used for other things. So code walkers, essentially, which makes sense because parse macro itself is a code walker and a close macro, and it's leveraged in that case. So we tried symbols, and we were symbol macros, and we're able to get this. What about regular macros? Well, we have that too as well. If I just inject my next thing. In here, in this example, what we did is we created a macro. Now, I've covered macros and use of enclosed macro and parse macro before, but we had some issues there. But I think I got some of the stuff kind of hashed out. So let me explain what I've done so far. So let me first talk about enclosed macro, just to put things in perspective. If you look at the CL environments documentation, enclosed macro is essentially a wrapper around the form pattern of enclosed to parse macro. This is actually a typical thing for actually creating macro functions that can be passed into an augmented environment for the purposes of writing code walkers and being able to actually leverage them where appropriate. Here, what we're going to do is we're actually calling enclosed macro to actually go and create a new macro, has a macro function called lwen that takes in a condition and body and essentially does what mywen did for us before at the top level, but locally inside the augmented environment. If we try and grab this from the environment now and we actually go and print it, we'll actually see that now we are actually going ahead and grabbing this and saying that it is a macro, it is true, and so forth. Before we move forward, let me just look at something here. This. I'm just going to comment this guy out just to see what happens when I compose. It is printing multiple arguments here. It's printing simlist and then it's printing the augmented expand. So that's weird. That means we're getting two values from print. Where is that coming from? This must be coming from. Okay, so one thing I could try is do this. Yoink. Print this. Let's see what happens when we actually use this inside the REPL. Forgive me ahead of time for the indentation. The indentation tends to get screwed when I try to do this kind of stuff. Okay, now we got that. Now we have this. Okay, now if we do this, we see that the augmented macro expand environment, it returns simless, but then it returns also two additional values, the expansion and whether or not it was found, which I think is coming from the macro expand function that's actually available in Common Lisp. So if I do, let's see, mywen, which we've defined earlier, print okay. And we see that we end up getting mywen and nil. Okay. So this is printing out simlist because of I said print simlist before it actually returned it. Okay, that is probably why. So if I just did one second. And I do clear REPL here. Okay, and let's do this one more time. Then we can check out ways to potentially use lwen. Let's do this and see what gets returned. Yeah. So here, as you can see, when we do a macro expansion, we are actually directly calling, we're essentially taking the simlist, right, lookup comment and just literally doing a substitution between the symbol and the list once we've actually grabbed it. I think it's a second here. Right. Now, can we do the same with our macro expansion here? Well, first, let's try using augmented macro function. So what is macro function first in normal common Lisp? Okay, let's go and look up macro function. Macro function basically does the following. It is going to attempt to grab the expansion function by doing a lookup inside the environment. All right, and if we don't specify an actual underlying environment, it will use the null or global environment to actually go look up the symbol. So let's see what we can do with macro expansion on a simple thing. Let's say we do macro function function. Why is this not giving me? Okay. My apologies. It looks like my buffer got screwed up. Yeah. Okay. Macro function. What does this guy do? We grab the symbol, let's say my when, and see what happens. And we see that this is not actually a macro function. There's no expansion function associated with it. If we attempt to grab this guy here, it's going to end up throwing an error saying that my when is unbound variable. So let's see what would happen if we use augmented macro function here with CL environments augmented macro function. Let's see L1, and let's pass in the environment here, and let's see what happens. Oh, sorry, wrong thing. What is it complaining about? In closed macro, the value in closed macro L1 blah 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 is not of type function. Okay, so it didn't actually take in this as a function. That's weird. Let's see. We got rid of this. Wondering what will happen, because I think what's happening is since this was defined in a meta quote, in a quasi quote, it's not actually returning the macro function provided by enclosed macro. Okay, so let's see what happens here. Now we're going to get a weirder issue. Lwin illegal function call. Yeah, so we're just going to complain about that anyway. Okay, interesting. Let's see here. What is it complaining about? Deleting unreachable code sinless. Deleting L1. Deleting. Error function calls. Hashtag nil. So it did not like that, but when we try to grab this, we are getting function information from this function, which is weird. Okay, so let's see what happens here when I try passing in the symbol. The name of the symbol. Let me try passing in an actual name as a string and see what happens, shall we? Let's see. What error? L1 is not a type symbol. Okay. So we could get we do this. This is doing a straight up substitution, which is not what we want. We want it to be evaluated. Let's try macro expand instead. Macro expand. Let's do this. And 5, print OK. And we know this here is going to probably require us to not do a lookup here until we get the ENV and see what happens. Oh, sorry. Okay, so here we have L1 with less than 4 or 5, augmented macro expand. So Simla seems to work, but if we try to do a macro expansion without providing arguments, what will happen? Let's see if we can do this with enclosed parse macro instead. First, take this guy out. Won't like us, but that's fine. Let's do this. Let's wrap slurp the entire code. Let's see where this is at. Okay. We need to unslurp control star, control star, control star. There we go. Parse macro, CL environments, colon. The notation for parse macro and enclosed macro is the same thing, so you could literally do what I'm currently doing here, and you should be okay. And this, is not an external, so that's right. Do that, and you'll see an illegal function call to parse macro. Okay. So, let's do this. Let's grab this here. Let me go and look at the okay. We have augmented environment and environment. Showing code. So, 1 second. Let's see here. This can be converted into a function object. Suitable to be passed has a macro function.
Okay, so let me see if I can explain what this is going on. I think there is an issue here. So it creates, so parse macro creates well, essentially the same thing that def macro does. It actually parses a macro definition form that, and it spits out an actual macro for us. So if we actually take this, for example, and by the way, in our implementation, I'm using SBCL here. If we pass in this, you will get, oops, oh, right, because this is not a symbol. It's going to attempt to do that. And body here is, okay, so we're back into this issue here. So this is related to the fact that parse macro, although it's taking in the macro definition form, it is evaluating it differently here in this case because it's not in a quasi-quoted string. Let me see this. Is this a function or a macro? Let's see. Okay. Let's try moving this guy out here. There we go. That's what I was looking. And let's do this. And let's go ahead and do that. And let's see what happens. And I do this. It does parse macro len quasi quote list quasi quote that. Okay. So parse macro itself is nothing more than a macro that will generate the quasi quote to SBCL2 colon parse macro. Okay. So if that's the case, let's do this. Let's call SBCL2 colon parse macro directly. And this is going to throw up an error saying that L1 is unbound because, again, this is not creating a symbol, make symbol. We can actually use make symbol instead. L1. And we'll get L1, or we could also use symbol name for L1, and we can also get it as well. So let's see if I can actually use so you need a name, you need a lambda list, you need an optional. So the name has to be the name has to be, let's see, let me see if I could do this. Make symbol L1. Just for the sake of understanding what this is doing. And this is going to throw an error saying that this is now body is unbound. So undefined function. Okay, so we can do this. We need to, that's why. Let me see if I do this, what happens? Nope. Let's define this. Let's see what describe SBCLTL2 colon parse macro. If we understand this, we can actually end up using CL environments directly. We'll parse its form argument, binding the variables in lambda list appropriately, and then execute body with those bindings. Okay. Let's see what this is doing. Let's try the simplest example here. Sometimes it's easier just to go ahead and try the simplest. So we do this, call parse macro, say that we are making these both, and what happens here? Body is unbound. Okay. See this. Let's see this. This is also going to say BDY is unbound, which is funny. Okay, I see. Let's see. This has to be a lambda list, right? Yeah. So let's actually make this into a proper list. Body. Let's see what happens. CND is unbound in the actual body itself so it's looking for CND and body in the forms, and we are not able to actually grab them. Okay, so the easiest thing to do here now is look up Okay, so let's see. Let's go back to using enclosed macro because it looks like enclosed macro should do the same thing that we are doing here with our standard thing, our standard SB extension. And this is taking the lambda list, and the list, our body is itself a list, and if we try to use it, it's going to end up trying to recreate this. Let me reread this. Parse a macro definition of the kind that might appear in a def macro form into a lambda expression of two variables, a form and an environment. The lambda expression will parse its form and argument. So it's parsing the macro into a lambda expression. But by doing so, it's attempting to bind the variables in the lambda list appropriately. So this must mean I have to provide variables inside my augmented environment to define this function. Let's see that. Let's see if that works. Because again, it's a code walker, right? So let's see if we define our CND here, and let's do this. This is here, and again, we're gonna take this guy out because we really shouldn't be using this instead. We wrap it in macro here. This is a label. This is a lambda list. Okay, and let's see what happens when I define, let's say we do 4, 5. Okay, body being the list, progen, print, okay. So now we have our stuff defined in here. And then, of course, we need to put this in our environment, body and CND. Let's see what might happen when I do this. Enclose macro is not of type function. Okay. Let's see if I can do this directly within the scope of if this doesn't work, we can always try and see if there's a piece of code in our piece of code inside the test suite that we could understand too as well to see if this works. Okay. What exactly? Oh, okay. It looks like it compiled, but what did it return? Let's see what it returned by doing this. And we are actually getting a lambda expression. So let us attempt to use that lambda expression, shall we? And let's provide env in this case as our optional env to enclose environment. And C, let's do this. Let's do a let. let this be a macro function, because it's going to generate a lambda expression for us. Okay. All right. So far so good. Now we're going to call print. Let's see what this does. Yeah, print CL environments augmented macro function on MF given REMV, and what happens? Oh, my apologies, I sent the lambda, not this. Okay, so what did it actually augmented? Okay, what is the augmented macro function supposed to return again? Macro function. It returns the expansion function. Okay, so I provided env, but it looks like it didn't actually, sorry. I provided env, but it looks like it didn't actually grab the environment, the macro function from the macro function that was generated here. But I think that's already a macro expansion function. What about L1? L1 gives me nothing. If I do this, this gives me gives me that this is a function, not an expression. So let's see what we can do with this function, shall we? So we now have a function that was macro expanded. CL environments. Enclose macro. Go back to this. SBCLTL2 Parse macro. This is ultimately what it's getting called. 6. Oh, right. This. Okay. Okay, so let's do a fun call here just to see what happens. Let's do, yeah, let's do that. Let's see what happens. If we do a fun call on MF with no arguments and see what will get thrown. Invalid number of arguments. So it is a form. Let's go and set has to be a form, so and say print hello and the environment as well. See what it does. If is unbound. Okay, so it is at least calling the function. It's not actually, it's just that it's not grabbing this from the actual lexical environment that's there. Let's see if I do this, what happens. Invalid number of arguments. So it has to have both the environment that we're providing, and it will complain or not. Okay. So here at the end of this journey here that we have essentially a macro function that's being created by enclosed macro. It looks like for some reason during the macro expansion of this, it is the symbols that as I defined them look like they're not being pulled in from the top level, although we've created an augmented environment here to actually grab it. So that's a bit interesting regarding just in general regarding CL environments. I don't know exactly what is causing that particular issue there. I have to do some debugging there, but um, the the actual form itself seems to be going through, which is actually good news for us. The other thing that this should be doing, because as you can see here, this is correctly generating a macro for us, a macro function for us. So I'm wondering if if we can actually use this inside of our top level that we had here that we defined earlier. If we end up doing this, then we have our obviously our we've actually reached another milestone here with deciphering this API, which is that we can actually end up using portions of it for code walking, but okay, and do this. Okay. Okay, good. So let's see here. Let's see what happens. Okay, so this is complaining about that, but that's because we have this here. Do we need that anymore? Let's see, what is it complaining about? The illegal function call. Okay, that's weird. Oh, got it. I now know what I need to do. So this that we created. Cut this one more time and do one more thing here. We're going to create our lambda function at the top level. And then we just do mf. See what happens there. Oh, let's do this. This is going to be, let's see what happens there. An illegal function call. MF is not a function of type no. Hold on. This is a function. Because it's a lambda expression, I just didn't appropriately define it as that. And let's see here. This hold on. This should be a cons pair, if I remember correctly, for CL environments. Give me this 1 second. Okay. Macro function. So list of macro definitions. Each item of this list should be of the form. Okay, so first, this should be a list of macro definitions. And each item should be of the form a list of lists. So let's see what we get here. And we know that hashtag MF is not of type, what? Okay, 1 second here. This is weird. Let me, before I do anything here, to try to do this, I would like to know print type of and the object. Oh, right, sorry. There we go. This is of type compiled function. So if it's already a compiled function, then it should be of type function, isn't it? So why is that not saying? Okay, let's see if I could do this. And this should be function type is not of type function or no. This here. Okay. It's not seeming to like the fact that I'm attempting to actually provide a function here, has a function object. Let me see if I can quote this guy, although this would be pretty useless because this is also not type function, right? So that's problematic. Let's do, oops. This is a let star, and we're providing an actual function here. And I know it's a compiled function. We've actually gotten proof that it was a compiled function already earlier. So what is causing this problem? Let me do this and see what happens. Okay, I'm getting close to it. Okay, now I think I figured it out. I have to do this. See what happens. Okay, we got it working. So, why is this happening there? It's attempting to use eval on the if condition, but if is available in terms of symbols. So unless the null lexical environment can't find if, which is kind of weird if that's the case. Okay, before I do this, there's one more thing I need to do a lookup on, which is, let's see if we can actually do, because I think if is a actual, I think it is a, is it a function? Describe if, or is it, it's a special operator. Crap, that's right, it's one of the 25 special operators. I forgot about that. So that means the symbol has to exist in the environment. How do I look up that particular symbol in a given environment? We only get variables, functions, symbol, macros, but we don't get symbol information. Oh, yes. We can actually go and grab it from the variable information because we can actually get type symbol. If env, let's see what happens. Nil, nil, nil. That is a problem. If I try to provide this in the nil context, undefined variable common Lisp if ooh, there it is. If 4 is less than 5, then prog and print OK. That's wrong. Okay, so that expansion is wrong. So let's see here. Do this, control that. Okay, and what is the actual expansion again now? Let's go and look at it again in the block expansion. This is where the output helps you. You can actually go and look at physically what is going on in the actual generated code. Unfortunately, it is defined but not used. Here we go. Let's do this. this guy out, and we see that this is going to be body not bound. Sorry, that's right. Okay, I think I know what I have to do. This is a little dirty, but we can. This can work. This essentially is going to attempt to do. Let me see if I could do that. Compilation failed. What is this? Oh. So that's the case, and it's trying to convert it. Let's see if I could do this. Program. Sorry. Do this. Stay that. Do this, and then do program, and see what happens. Okay. Let's see what the generated code looks like. Undefined variable print. Okay. It is variable body is defined but never used. Let's see what happens if I get rid of this and get rid of this. And let's see what happens. We have a unbound conditional C and D. Okay. Four. Sorry, my REPL got again converted into a problem. So let me just go ahead and do that. Oh, declare this. Oh, Control C. Oh, declare the REPL and okay. All right. So now let's see what this does again. It's going to complain about body not being provided. Okay. And here. Oh, I'm so dumb. This guy is probably what's causing that problem. Now, let me do this. Body being progen print. Okay. Let's see what happens. Let's see where it is failing. Much better. It's getting there at least. The prog end is still being spliced because it is treating that as the top level body that it's trying to extract from. So instead, if I just wrap this as a list, I wonder if that would actually work. Like this. The body is also a list in a macro definition form. Okay. And commas on side of back quote. Okay, so I have to have this back quoted. That's right. Okay. Let's see what happens here. And there we go. We cleaned it up a little bit. Now prog n is doing progn with print. What it is complaining about. Okay, so let's see if I can do. Let's see if I can get rid of this. Let's see what this comes up with. Okay, now this block looks cleaner. But what's interesting is this is taking all of the macro, the forms that are in the environment, and where it's essentially forcing a macro expansion at compile time. Sorry, at the time that we are defining the environment. So I'm wondering what advantage that has. That's an interesting thing, though. So C and D variable is not used. Of course, it's not used because we are it is not treating the environment upon which we are. Oh, got it. I think I need to do this. If I did this inside the optional, that's the purpose of this optional env that's provided here. So in our env, so if I provided this, and then I use that in my macro definition here, at this point, this macro function that's being created, that's already going to be code walked, and it would have bound those forms expressions, created the macro function, and then associate that in with the symbol that we just defined. But we're doing it outside, so this is going to end up creating stuff that's no longer going to exist. So just to give you guys an update here on what this is, what I'm talking about here, is you see this list here, the lambda list that's represented for def macro. This lambda list is supposed to essentially, at the time that the macro is expanded and the lambda expression that we're seeing here gets created, this guy is essentially taking expressions from the underlying environment, specifically these two, which is coming from the lambda expression, and it is supposed to bind them to some expression that's available in the environment. But it's, like as you can see here, we are actually not leveraging this piece of the code that's being generated by Parse Macro. That's why we're getting this warning message saying that body is not expanded. But we don't need it. So let me go ahead and take this guy out and see what the difference is. Because we've already kind of did the majority of the work for the time being. We're simplifying this example. As we do more advanced code walkers, and I have to give me more experience in writing code walkers in this library, then I may be able to figure out this particular issue. But since we're all learning here, it'll be better just to simplify things as quickly as possible. So, what is it? No unwarning. Okay. So this is all good. Now, one thing to note: this could be a list of lists. In which case, if you did
like this and say, loop, for I from 1 to 10 collecting I, and then print OK. This here can then be expanded by doing array splicing, as everyone knows, by doing comma at. And this will give us essentially the same fundamental expansion that we were supposed to be getting when we enclose a macro. This is actually why this is written this way, because behind the scenes, that's what it's actually doing. It's taking the body, which is a list of lists, and it's doing a macro expansion on them. So now here, if you go and look at our condition, print OK, and we see our block. Okay, looks like the block is not actually showing up unless I do this, which is weird. Okay, you can see here that this is actually creating what we expect it to. Okay. So the only thing remaining now is figuring out why this defined macro function is not actually being leveraged. So that requires us to go back to what this is. And let's see if I could do this. And let's see if I could just create that. And let's see what errors I get here. Illegal function call. Okay, if I create this, we know that MF is not a function, although it is. Let me see if I could create a cons pair out of this and see what happens. Invalid function call. Okay. This particular thing is supposed to take 2 arguments, converted include macro. Enclose macro is supposed to do what now? Parse macro into a single step, right? And it returns a function of proof. Okay, so maybe I don't even need to do this when. And maybe I could just say mf of type list. Okay, so I do need it as a type list. And do this, because this is a label, it's supposed to be a symbol. There we go. I think I forgot that I had to create, that's not a symbol that I was defining. The name has to be a symbol, not a name. Let's see here. Let me just double check this. Yeah. Anytime, this is one thing that I get frustrated with this this thing. Anytime you see names, sometimes it means that it's supposed to be a symbol instead of a function. Let's see here. Symbol macro. But what's interesting about this is when has a macro anymore, it's treating it as a compiled function. Which is it makes sense because of the fact that len now is no longer a macro at all. It is a function.
and it is defined in the global scope now because we had to define it here. We defined it here. Now, let's see if I can actually go back to actually doing this. Let's replace this with that. And let's do this. And let's make sure I can do that. And let's see what happens. It is still a function being created because the macro is no longer there. So, I'm going to mention that this piece here on code walking is a bit of a challenge to actually get right. So as you can see that I'm struggling a little bit here to actually get it corrected. But I hope you could see that this is more or less doing nothing more than string substitution for the macro stuff before it actually constructs the final macro function that we're having trouble here binding to this particular macro for some reason. That I will go ahead and make a note of just to see what I need to go and correct, and I will write a note. I'll probably see if I can do something later on this. The one thing that I'm going to mention about declarations here, okay, because I was just reading this earlier today, and I think that's something that I didn't realize was the case. The declare here isn't specifying declarations as defined by declare declarations. The declare in the environment is if we want to take any symbol and provide declaration specifiers, we can do so. So like here, as if we're using declare directly. So this declare list here that we see, okay, this can probably be taken out and just put in as this, a list. And if we go and now look up print variable information a list env, we should get now lexical environment, and we get ignored t, right? Which is essentially for the given augmented environment, we can actually go and provide additional declaration specifiers without having to provide them early on, like at the top level of the function. And we don't necessarily also, and this is more important, we don't have to explicitly put them in our in environment form. Okay, so another example of this is also the stuff that we did with our author example, which I think is somewhere here. I have our define declaration here. Yes, what I do. Right here, if we use author, when we do this, we could see that test function doesn't have it. But if we provide, say, unfortunately, author, I think I designed it incorrectly because it should actually take in the symbol that it should be augmenting on, and I think that's the reason why it's not augmenting it in the particular symbol itself. So let's see here. We define declaration we're supposed to take in the decal name, the argument name, and the body. We need to correct this. So for custom declarations, I still have a little bit. I have to go and correct a little bit more correctly. I'll get back on that one, just because that one is not a big deal right now. Very few people, unless you are writing compilers or you are writing metadata information that later on that you're going to create probably a compiler macro to extract it. Declarations are essentially hints to the compiler. They're not really used for a lot much else. So just keep that in mind when you are dealing with declarations. I think I covered the majority of things here. The one thing that I did not cover that I think requires a little bit more of a longer discussion, and honestly a more concrete example where this becomes very useful, is in the environments API, there is a bunch of functions related to getting return types, value types, and essentially all this is ultimately culminating in what would be considered a good exercise in code walking. And I need to still come up with a fairly decent example for code walking where we could then leverage the CL Environments API called walk environment and leverage the hook functions that will essentially override macro expand hook in a scope, allow you to take macro expand hook and provide a different expansion function than currently is available. So that's it for our discussion on CL environments. Tune in next week. Sorry, not next week, because the next couple of weeks we have actually 3 weeks we have a brief hiatus, and we'll be back in December. At which point I'm going to be starting to cover the Colton library, which allows you to essentially do static type checking using a Haskell style approach inside Common Lisp. And this library is a pretty interesting library too, because not only can you essentially write function signatures with type in much the same way in Haskell and use macros just because it's still at the end of the day compiled to Common Lisp, but also it provides some features that I think look a little bit more user-friendly than some of the stuff that we've seen in Fari's Lisp interface library, particularly in the world of doing monadic transformations. So that's going to be a fairly exciting discussion. I'm looking forward to it. So until next time, are there any questions? Okay, well, I'll see you guys in